My name is Mike DeLacluse. I'm the president of Lesman Instrument Company. I'd like to thank all of you for taking time out of your busy schedules to join us for reliable, redundant tank level indication. Today's speaker is Paul Deimling. Is that how you say your last name, Paul?
Deimling.
Deimling, thank you. Of Jerguson division of Clark Reliance. If your idea of tank indication is an operator looking through a cloudy or cracked tubular sight glass or dealing with faulty mechanical level indicator with stuck flags, this webinar is for you. In the next 45 minutes or so, Paul is going to talk about using magnetic level indicators to replace problematic tubular glass sight gauges, some design innovations that improve magnetic level indicator reliability, talk a little bit about local level indication for difficult service applications like cryogenics, dirty service, high temperature flashing liquids. Paul joined Clark Reliance as an application engineer in 2011, currently serves as product manager for the Jerguson magnetic level gauge products, has a bachelor's degree in mechanical engineering from Case Western and an MBA from Baldwin Wallace University. We thank Paul for joining us and sharing his expertise with our customers. The phone lines are muted. If you have any questions along the way, please use the question tool built into GoToWebinar, and I'll make sure we get them answered. With that, I'll turn it over to you, Paul.
Thanks, Mike. Appreciate that. Yeah, this presentation is something we put together. I've given it to done it at refineries, I've done it at EPCs, I've done it at headquarters of major oil and gas exploration companies. It's designed to discuss, you know, the story I like to tell is I was at, like again, a major exploration oil and gas company, and one of their head of instrumentation, and he was probably joking a little when he said this, but he said, you know, glass gauges, mag gauges, he goes, nothing in that's changed in 20 years. And there is there's a feeling out there that, you know, it's sort of a simple product that that hasn't changed much, and this presentation will show you otherwise. So we'll get into it. I've skinnied this down to hit just the some of the top level bullet points. But if you have any questions along the way, we can certainly stop and discuss anything in more detail, or we can discuss it at the end. So what you see now is a representation of how a magnetic level gauge works. So you have a chamber, clear of course for this visualization, a chamber attached to a level tank. As the green fluid in that column, in that tank rises, the fluid in the column rises as well. The float is designed to float at a specific point on that fluid. You'll notice some of the float is above the liquid. It's called freeboard. Inside the float, there's a series of magnets. Different brands have different ways of designing that magnetic field. We'll talk about ours. As it moves up and down, the magnets in that float are coupled to the magnets in the flags. You'll see those flags turn over, black to yellow, showing you your level going up, and then, or I apologize, yeah, black to yellow showing your level going up, and then yellow to black showing you your level goes back down. There's also coupled on the side some snap action switches that are activated by the magnets. You can also have a transmitter on there. So again, this is just a 3D representation. We're going to discuss all those different points in detail throughout the course of the presentation. So the number one problem I see in the field, typically, like I said, you know, when we're in refineries or chemical plants, is flags being out of sequence. So one of our customers was kind enough to send us this photo, and what it shows you is, you know, what happens when you have a weak magnetic coupling between the float and the flags. So, you know, if you're an operator and you're looking at this, it's black on the bottom from 0 up to about 13 inches. And then you have about 7 or 8 inches of yellow flags, and then it goes black again. You have another, I don't know, call it 7 or 8 inches, and then it goes back into yellow. So, you know, assuming your level's static and you had another period at the top where you had yellow flags break to black. You know, if you're an operator, where are you supposed to look at this and think the level is? Now, obviously, if the level's moving, you can see those flags turning over. You would know, but you could easily look at this if it was static and think that your level's at 0, 13 inches, 22 inches, so on and so forth. So you'd have to manually reset this, you know, take a flag, reset all these flags to where you know the level to be, or simply wait for the float to cycle down and back up. Of course, if you have switches on the side, this is problematic, the weak magnetic coupling, as well as if you have transmitters on the side. They rely on that magnetic field from the float. And this is, like I said, this is the #1 problem that I see when I travel out into the field. So the solution begins with a better magnetic field coming from the float. So the Jerguson design uses a unique arrangement. We take 2 Alnico 8 ring magnets. Alnico 8 is a permanent man-made magnet. Alnico stands for aluminum, nickel, and cobalt. The 8 rating is it's a combination of, it's not simply a strength rating, but you can kind of think of it that way. But it's a permanent magnet. It's rated to 1,000 degrees Fahrenheit. We take 2 of these ring magnets. So it has a hollow core to it, but we space those ring magnets with the north pole opposed at a fixed distance. So this shows you our standard arrangement. We use a 1/2-inch aluminum spacer. We do have other, based on wall thicknesses and other things, we do have different spacings that we use, but this is our standard arrangement. And when you take those 2 north fields and you push them together, you know, hopefully everybody here has kind of played with magnets at some point in their life. You get that repulsion, that repelling that you feel from the magnetic fields, and that repulsion is magnetic flux. Principle of magnetism is just like electricity goes from positive to negative. Magnetic field flux goes from north to south. So when I take those 2 north poles and I push it together, another principle is those flux lines can't cross. So when I push them together, that repulsion you feel is those flux lines pushing back, because I'm trying to force them together and they're saying, no, I can't. And what that creates is, we're taking that field and we're pushing it out far away from the center line of the float. So again, it's a hollow magnet, so here's your center line and here's where the bodies are. So when I'm forcing that magnetic field out far away from the center of that float, I create a very strong north magnetic field out here, out where the flags are. And that's where you want to have your magnetic field, not only strength, but focus. So circling back, I mentioned Alnico 8. There are other grades of Alnico, but the number that is most important here, there's a couple things. So one is your max temperature. Again, this gauge, our entire gauge is rated to 1,000 degrees Fahrenheit as a standard. So you want to know that your float magnets can withstand your process temperature. So there are other magnets. You know, one question I get a lot in the field is, well, what about rare earth magnets? I hear those are really strong. And rare earth magnets are really strong, but they're generally fairly expensive for the size, and they typically have a max temperature below even this neodymium. So they usually have a max temperature that you can melt them in your oven pretty easily. So it doesn't work in a lot of the process industry, whereas Alnico 8 has a max temperature of over 1,000 degrees Fahrenheit. The big number you want to see here is this, what's called magnetic coercivity. So Alnico 8, the reason we use Alnico 8 is it has a very high magnetic coercivity number. Other manufacturers use Alnico 5. So the problem with the lower grade magnet is, under the presence of both temperature and magnetic field, that Alnico 5 magnet can lose its magnetic field. So there's actually some brands out there who, you know, customer will say, well, my float decoupled, there's something wrong with my float. And they'll say, well, you just send it back in, we'll recharge it. And they put it into a machine and it puts a new magnetic field back into those magnets and they send it back. So on our design, because of that high magnetic coercivity, you don't have to worry about that. So again, I talked about how we're worried about this you're worried about where that magnetic field is in relationship to the center line of the float. So because of that strong magnetic field, you know, our standard design is a 2.5-inch schedule 40 chamber, but we can also do a Schedule 80 shown here and a Schedule 160 shown here. So with that thicker wall. And all we need to do is manipulate the size of the magnet as well as the spacing of the magnet. So regardless of the pipe schedule, we get that same reliability that we get on our standard in a high pressure application. So the other half of that magnetic coupling, right, is you have the float, but the float has to be coupled to the flags. So when we look at our individual flags, we use a stainless steel stamping. So here it's painted yellow. It's also available in other colors, but here it's painted yellow. Stainless steel stamping with a permanent magnet, ceramic magnet pressed in. Excuse me. We take a rotation pin, we slide it through that magnet, and this flag rotates about that rotation pin. We take that rotation pin, we put it into an aluminum track, and that pin's able to rotate in the track. So you have dual rotation points. So I have a strong individual magnet that's coupled to my float. I have a stainless steel magnet with high temperature paint that will last the duration of the installation. And then I have multiple rotation points. And these are all different steps that we take to ensure reliability, that you don't have those flags getting out of sequence. That flag is able to rotate. There's no mechanical binding reason it wouldn't rotate, as well as there's a strong coupling between the magnet of this flag and the float. So as this gauge sits here right now, because we're showing it in yellow, like I told you, your float makes a strong north field. Well, the top, this is going up. This side of every one of these magnets is the south field. So as that float comes back down, that south field gets pulled down and it turns over as it moves past. So if you guys can see hopefully you guys can see my mouse. Okay? And that's simply how it works. I mentioned that magnetic field strength is important, but the principle of one thing about magnetic fields is it's not just the strength, it's also the direction. So you want to have as much as possible, you want to have a tangential magnetic field here, out where your field is, because that's what's going to pull that. You want to be pulling those flags this way. Okay, you want to turn them. So what does that get you? So this is just a short video of one of our demo pieces. I can move this up and down as fast as I want, and I don't have to worry about those flags decoupling. Okay, and that's what we're talking about when we talk about the reliability of that magnetic circuit. So you need to have, when we talked about at the very beginning, we talked about the different pieces of a magnetic indicator. You have your chamber, you have your indicator, you have your float. So we've talked about the design of the magnetic coupling between the indicator and the float. But just as important is you need to have reliable chamber design. So like I said, our standard chamber is 2.5 inch Schedule 40 pipe. Schedule 40 is shown here. We do not use Schedule 10. There are some manufacturers who offer Schedule 10 as a standard. And I've been into many refineries that don't allow Schedule 10 in the plant, but during the quoting process, they didn't pay attention. They may not have specified Schedule 40. A vendor sends in a quote using their standard Schedule 10. The purchaser misses it, and they buy it and install it. Only after they've written the check and gotten the product do they find out that it's Schedule 10, and now, of course, they have to go in and fix that problem. So something to pay attention to. It does happen. Even if your standards call for it, you have to make sure that it's complied with when you place that purchase order. We can do, like I said, 2.5 inch Schedule 80, 3 inch Schedule 80, 3 inch Schedule 160 for high pressure applications. And again, that gives you a nice visual of what Schedule 160 pipe is some pretty thick stuff. We've dealt with many manufacturers, I apologize, many plants. Some have come to us and saying, we've gotten no bids from other manufacturers saying they can't do Schedule 160. So all designs comply with ASME B31, B31.3. So that's what we use as our design basis. We'll talk about that when we talk about nozzle design in a minute. All of our nozzle design has been third-party verified by a professional engineer. We have all those testing certificates. Chambers are hydro-tested to 1.5 the ASME flange rating as a standard. And all of our welders are ASME Section 9 certified. And again, this is all tied back to creating a reliable device that you can count on for many years of service. So speaking about nozzle designs, so again, these all comply with ASME design as well, and all the engineering has been third-party verified. For 150 pound and 300 pound class gauges, you would expect your nozzle connection to be, so our standard would be a slip-on, so this is a slip-on type flange over a pipe nipple. The pipe nipple is saddle weld prepped, and it's a full penetration weld to the chamber. You can see the full penetration weld shown here. So it is a full penetration weld, but it's not an X-rayable weld. That's sometimes a point of confusion. And again, this meets ASME for 150 and 300 class magnetic level gauges. When you get above 300 pound class, when you get to 600 and above, ASME requires a self-reinforced fitting. So we have to go to an OLED or a weld OLED. So that weld OLED is a full penetration weld to the chamber. In this case, you then have, so this is now a socket weld type. You'll notice that this opening is a little bit different because you're not doing the slip-on style. So you have a socket weld to the nipple, to the OLED, to the chamber. And that's going to be your branch connection. Now, in both of these scenarios, you're limited on the size of the branch connection you can safely put onto the pipe. So our standard for a 2.5 inch, unless you specify otherwise, even for 150 and 300 is going to be a 1 inch nipple. Okay, and that's true for the OLED as well. So we use a 1 inch nipple. So this is a reduced size. So even if you have a 2 inch flange here, it's still going to be reduced down to 1 inch. Sometimes customers call for either two things. They want a full bore connection. So whether it's 1.5 inches, 2 inch, but they want or even 2.5 really, they want a full bore connection. Or they have a scenario where they want all the welds that are done on the entire chamber to be X-rayable. In that scenario, you go to what's called our full bore butt weld T construction. So we can get a butt weld T in a 3 inch, 2 inch, 2.5 inch, reduced to any of the outlet sizes. Okay, and this will now give you a full bore connection. So if you have a dirty service and you're worried about plugging, you want to have that oversized, or I should say non-reduced size going to your branch connection, this is what we would do. Okay, so the benefit of all of these designs is the strength of this design, up to about 20 feet, depend on flange class, but up to 20 feet, you typically don't need support brackets for standard magnetic level gauge because of the strength of these branch connections. Now, obviously, if you're in a vibration service or something else, if you have a dual chamber, we would recommend brackets. But up to 20 feet, typically they're not required. So that closes off the chamber section. We talked about indicators, but one of the biggest benefits of going to a magnetic level indicator over a glass gauge is, on top of, Mike kind of touched on this at the beginning, the old style tubular gauges, they got pretty dirty. They came up with brushes, so you go in and brush them out. Obviously, operators don't love doing that. That takes time. You have to shut it down, isolate it, brush it out. Magnetic level gauges, of course, you don't have to worry about that contamination. It doesn't mean they're maintenance free, especially in dirty service. You still may have to flush a magnetic level gauge from time to time if you have buildup, but you typically get a longer life of time between maintenance where you'd have to flush that out. But again, one of the other benefits is because you have that magnetic float inside, I can now put devices on the outside that use that magnetic float for function. Whereas a glass gauge, obviously, it's a window into the process, but I can't put a switch or a transmitter or anything that works off of that window. So the SAS16 is a snap action switch. It simply clamps onto the side of the gauge. It's rated to 750 process temperature. There's no cams, springs, no movable parts. Simply, and you can actually see it in that first slide the best, but there's a primary magnet right at the chamber, and as that float moves by, the outward tip of that magnet is attracted to the float magnet. So as the float moves up, it moves up, and as it moves down, it moves down. Inside, on the opposite side of the back of that primary magnet, there's another magnet that is repulsed by that same side. So I have a north field for my float. The south field's here. I have another north on the inside, and then I have a magnet with a north. And as this inside one moves up and down on the pivot, the switch is made by that action of that repulsion force. So I simply move, as this moves up and down, it moves my contacts up and down, and it activates our switch. So you get excellent vibration resistance because of this repulsion force. It's not a micro switch, so there's no micro switch you have to worry about having a life cycle limit to it. Single pole double throw configuration, so there's a normally open and normally closed option in the wiring. And you can see this in the standard with the 4 wires coming out, but it's also available with a junction box. Okay. You get excellent 10 amp rating. UL for North America, but we also have an ATEX unit if you were selling units that were going to Europe. So coming out this year, we've had on the market the MTII 4200 for a number of years. We're still officially selling the 4200, but we do have available the MT2 4300. It's our next generation of transmitter. I say available soon. We're still going through some of the final steps in the production process, but we have been putting it into the market for the past probably about 4 months. So one of the big step up is, this is a 420 milliamp device, continuous output. The old 4200 was Hart 5, the new one is Hart 7, so it brings it up to current standards. But on top of just, updating the display, it's got a nice bigger display. It has a user interface without opening the cover. The old one had a 3-button. Some of the big changes are the signal-noise ratio, substantially higher than the 4200, up to 5 times as high. So you don't have to worry about noise being as much of a problem and causing false trips. There's an adjustable rate of change filter, so you can tell the transmitter, if it's mapping along really nice at 24 inches and all of a sudden the transmitter thinks it's at 60 inches because of noise. The transmitter is smart enough to say, well, it's not possible. I can't go from 24 to 60. And depending on the setting, it'll ignore that 60-inch rating until it settles back at 24-inch when the noise settles down. There's a single-point calibration option. There's a factory reset from the touch screen. So, if you're out in the field and someone goes in and starts changing settings, trying to fix something, and it just gets out of control and they can't put it back, they can always go in and just do the factory reset, and this puts it back to the exact way it was set up for the factory. So even if you were rearranging it and it got fouled up during the rearranging process, you can go to a factory reset and then go back in and try to rearrange it correctly. You can replace the display without losing programming. So if the display, over time grays out or were to become damaged for whatever reason, you can replace that and your programming stays integral to the boards. So we're pretty excited about that. So that's the product part of the presentation. I do want to talk about some applications, some challenging applications. One is flashing or boiling service. So there's a video we'll show you here in a minute, but with the emergence of fracking and all the gas work that's been done over the past up to a decade really, we've seen a much greater demand for level gauges that can handle cryogenic applications. So one of the biggest markets out there is gas fractionation. Especially right here in Ohio, they're bringing the gas out of the ground. They're splitting it into different consumables: ethane, propane, methane, etc. So that part of that fractionation process is you have cold boxes that make those level gauges really cold. Well, if I have a fluid, we'll use propane as an example, that I have to keep in, let's say it's minus 40 F. So in my big vessel here, it's contained at -40 F. It's well insulated and it's chilled. Well, I have some piping coming off the side going to this level gauge. I have a much smaller volume of water, and even if it's insulated, I have a much smaller volume of water, I have a much higher surface area, where I'm going to have greater heat loss into that chamber. And what will happen is you'll slowly raise the temperature of this fluid to the point where you start to get some boiling or flashing. So with that, I'll go to the next slide, which is a nice little video, and then we can circle back and talk more about it.
If the liquid in your magnetic level gauge boils or flashes, you can forget about getting reliable level measurements for indicators, transmitters, or switches. How can this happen? It's a hot summer day. The liquid in your storage vessel is being maintained at a controlled cold temperature. However, the small amount of liquid within your magnetic liquid level gauge has warmed up to near or above its critical boiling point. Entrained gases from the boiling rise and collect under the float, reducing its buoyancy. This boiling fluid can sink not only your float, but any hope of getting an accurate level reading. The new Jerguson Magnicator Flash-Proof Gauge features a unique chamber design to eliminate problems from boiling liquids and flashing vapors. By employing an oversized 3-inch Schedule 40 chamber with internal guide rods, entrained gases easily escape past the float. An accurate float level and indicator reading is maintained.
Sorry about that.
As the guide rods hold the float to one side of the chamber to ensure an optimized magnetic field in close proximity to the indicator, transmitter, or switches. The Jerguson flash-proof design also eliminates crushed floats due to flashing vapors, which can happen when the float rapidly accelerates into the top of the chamber due to depressurization. Because your plant's operation requires reliable level measurement for indicators, transmitters, or switches.
So now it's going to scroll a couple, which you see on the other slide. It's going to scroll some applications of fluids, but generally the rule of thumb is, to use, you can use 0 Celsius, 32 Fahrenheit, whatever number you want. That should be the point where, alarm bells start going off. Okay, and that is to say, if you have a process that operates right around that 32 Fahrenheit, obviously if it's winter, we're based out of Cleveland here. I think it was about 20 degrees driving in this morning. You're not going to have any heat loss, so you don't really have to worry about flashing in the middle of winter. But in July, when it's hovering up from mid-90s, 95, you get some direct sunlight on that gauge. Process that's operating around 32 degrees Fahrenheit. If it's got to maintain a 32 to stay in a fluid state, you're certainly going to get some heat loss there into the chamber, and then, like I said, you'll definitely get some flashing, and that's where the issues come up. It was as simple as I had an application in Pennsylvania where they had a large bullet tank like this. It was a cryogenic tank. In the morning, the sun came up to the east, and the level gauge that pointed east worked fine. But by the time afternoon came and that sun was a little bit over the western side of the tank, and that gauge on the right side, the temperature had come up because it was now midday, and it was getting blasted with sun. The one on the east was okay. It was still warm, but it was in the shade now. But the one on the western side was flashing like crazy because it was getting hit by that sun as well as the full temperature. So it's just something to keep in mind. If you do have cryogenic applications, whether it's food service, you're talking about ammonia or carbon dioxide, we've seen a lot of those type applications, or if you have a process application that's cold. One thing to keep in mind is, and discuss with your customer is, do they want us just to provide a level gauge and an indicator? If you're going to do that, we definitely recommend we make a hermetically sealed indicator. I didn't touch too much on this. And I want to mention, that video as well as most of the other resources you're going to see on this can be found on Jerguson.com, as well as any of the products I'm discussing, the flash-proof gauge, our magnificator, the SAS16. We make a hermetically sealed indicator. It's a permanently purged indicator, so you don't have to worry about moisture condensing on those flags. So for cryogenic applications, we generally, especially when you're below 32 Fahrenheit, strongly recommend it to the point of almost making it mandatory. We can do what's called a non-frost extension. We put some piece of acrylic polished on both ends over the front. We permanently affix it to the front of that indicator. Gives you a window into that indicator should ice build up, or if you want to do cold insulation, we can do cold insulation here at the factory. If they're buying this to install it, I typically recommend letting us do the cold insulation. From a cost standpoint, it's going to be very similar, maybe even less than what they're going to pay to do it at the factory. And ours is done, we do a better job of sealing it up than a lot of what I've seen in the factory. So we run into issues where they don't really do a great job sealing this. Moisture gets in, they start to get ice buildup, and that ice buildup causes some issues, whether it's if you had a transmitter under here, it puts pressure on that transmitter or what have you. So something to keep in mind. So that we came up with that design, the oversized 3-inch Schedule 40 chamber with the guide rods. I didn't talk much about I'll talk about the construction now. It is 3-inch Schedule 40. We use guide rods at specific locations. It's a square guide rod. Creates a similar sized opening to what the 2.5-inch Schedule 40 was for the float, but then creates a massive amount of bypass zone for those flashing vapors to move around the float, like you saw in that video. This square guide rod is welded at the ends of the chamber, as well as it's back welded to the chamber, so we drill out the chamber and back weld it every 3 feet or less. So you never have to worry about those guide rods coming loose, bending, flexing, causing that float not to be able to move by. So we came up with this design for this, flashing applications, for the cryogenic applications. But something we discovered along the way was it also worked really well in dirty service. And the reason being is, I have this oversized chamber to allow flashing vapors to move by. Well, what about if I have particles? So if I have a dirty service, the one I always like to use is the reduced crude drum. You get down to the bottom of that drum, you have some heavy, you get a lot of heavy crude. You have paraffin starting to build up. You may have some sediment, you may have some silica, but you have lots of substantial sized particle now present in the bottom of that heavy crude. So this oversized chamber does a couple things. One, it maximizes the space between that float and the chamber. A standard chamber has about 1/8 inch clearance around. So if you start to get a buildup of that heavy solids, it's not too long before this starts binding up on the walls of that chamber. This greatly reduces that amount of space. But one of the other big benefits is, especially if you have very dirty service, like I said earlier, this is a lower maintenance product than a glass gauge, but it's not a zero maintenance product. So another benefit of this bypass zone is I can now do flushing without removing the float. So your drain is still centered on the chamber, but your float is offset. You have these guide rods keeping it in. You can add a steam port to the side of the chamber, and I'll show you in a couple slides what that looks like, where you can now run steam through this gauge. You don't have to drop your bottom flange. You don't have to remove the float. Simply drain your, obviously isolate the gauge, drain your gauge to the process sewer, and then you can simply steam it out. Run it for a decent amount of time. You can clean up all those solids that have built up here, built up on the walls, flush it out the bottom, close your steam port, bring that gauge back into service. So this is something we've used a lot more. And again, the two big ones are the bottom of those distillation towers, where for years they've had glass gauges that become coated within minutes of putting them into service and are impossible or near impossible to read. So that's been a really nice application that we've been offering. The last big point I want to talk about is combined technology. So, most of you been talking about magnetic level gauges, but we'll discuss a glass gauge here for a little bit. So we have a product we call MGWR, stands for Magnetic and Guided Wave Radar. So here on the left is a standard magnetic level gauge, 2.5-inch schedule 40. This happens to be a night star, which is our illuminated level indicator. But you also have a secondary chamber. Now it's tied to your main chamber, so you only have one common drain. Okay, but it's a 3-inch schedule 40 chamber. In this case, it's showing a Enders-Hauser guided wave radar on top. Now the benefit of that is I have a single set of process connections, so I don't need an extra set of process connections. But now if I have variations in specific gravity, or if I just want a redundant output, I can do that all off a single set of connections. So your fluid still enters from your bottom tap, fills up the bottom, and as it fills up the magnetic level gauge, it also fills up this bypass chamber. So inside you'd have depending on your process, you'd have a rigid probe. We have some applications where we do this with a rope probe for longer applications, or for applications where they have limited head space and they want to be able to take this flange off and just kind of pull it to the side. So we have done bottom flange units with rope applications. You'll see that on the next slide. But now changes in density don't affect your output. So if you had a magnetostrictive on the side, and this was an application where you got into a light end hydrocarbon and that float sank, you'd lose your local, but in this case your guided wave radar would still be operating, still giving you a very accurate 420 output back to your controller. So you'd lose your visual, but you'd still be functioning. And then when the SG returned to its normal operating, your float would come back up, and again your transmitter would be unaffected. So that's a big advantage, both in process, but one of the other places we see this a lot is feed water tanks on steam, where during startup this float may indicate 2-3 inches high, because the SG of water at room temperature is 1, but once you get up around 600 pounds, it's down maybe 0.8. Whereas the guided wave radar is going to be giving you, regardless of the specific gravity, guided wave radar works on dielectric constant, and the dielectric doesn't change. So you'd get an excellent level control even during startup. So that's very, very common in those applications. And again, this is a standard product for us, so we can sell pretty much everything you see inside this blue box on either on a 6-week lead time, sometimes quicker. But we also do some other applications. This was done for an offshore platform, and this is where I talked about with that rope transmitter. So you have to have a bottom access flange to tie in that transmitter. They use the radar as a primary connection. You'll see flushing ports. So this is a flushing port for the chamber, so they can put steam on. This was a flushing port for access for the valve. But they also put large isolation valves between the radar chamber and the mag chamber. This was an application where we had a guided wave radar chamber. Again, they have a vent here. And they wanted a glass gauge to verify level. They were going to run that radar 24 hours a day, 7 days a week, 365 days a year to give them control. But during startup or critical services, they wanted to be able to bring a glass gauge into service and verify where that level's at. So this must have been their operating range was down here. And we had another application, a feed water tank, where they needed to control that feed water at a very critical level. They had triple redundant guided wave radar and a magnetic level gauge for visual. Large carbon steel bridle. Everything on this, I believe, was chromoly. You'll see it's a 3-inch schedule 160 mag, so it was very high pressure. But we did this entire bridle assembly for them. I think they provided this feeder line, if I remember correctly. We just gave them a couple. So there are other options out there besides our standard what we do. So we can do different applications, different products to fit the application versus the other way around. So that is it for my presentation. I tried to touch on some of the key focuses about reliability, a couple applications there. Obviously, I didn't want to take the full hour in case there was any questions either about the presentation or otherwise. So with that,
Paul, I've got the question box open, so if anybody has a question while we're wrapping it up here, please enter it in and we'll make sure we get it taken care of. Thank you very much for your presentation. If you do have specific application questions, feel free to give us a call at 800-9-LESMAN. If you don't know your account manager, just ask for me, and I'll make sure that I get you taken care of. You can also reach me at my email, which is miked@lesman.com. If you want to know about the other technologies we supply, you can follow us on social media. Dan Wisey has a blog. He's fairly active, has lots of great tips. All of our webinars are posted on the training portion of our website and also at our Lesman Instrument Co. YouTube channel. So it's all out there, and there's now well over 100 of them on all sorts of different topics. If you do have a topic that you would like us to cover, we have access to all sorts of experts on all sorts of process-related products. You can just send me an email with the subject, and I'll get somebody lined up to make sure that we get the topic covered. At this point, I'm still not seeing any questions, so Paul, thank you very much for your presentation. I think we'll go ahead and wrap it up.
Okay. Thanks, Mike.
All right. Thank you.
Thanks, guys. Thanks for everyone for attending.